Hi everyone, I am Sreekanth. We are discussing about programming in C language. The topic is about algorithms. Today's agenda of the session is about different ways of stating algorithms. Okay, or sometimes in the examination they may call explain different types of representation of algorithms. Okay, both are same. Here we are discussing the different ways of stating algorithms like step form, pseudocode and flowchart. The previous video session we had discussed in detail about what is algorithm, right? Algorithm is a finite sequence of explicit and unambiguous steps required to solve the given problem. Or simply you can tell algorithm is a way of providing a solution like in the form of what? Step by step procedure providing a solution of given problem. See, generally these algorithms are represented in three different forms like step form, pseudocode and flowcharts. We try to discuss in detail one by one about step form. In the step form representation, the procedure of solving a problem is stated with written statements. Each statement solves a part of problem and these together completes the solution. The step form uses just normal language to define each procedure. Every statement that defines an action is logically related of what? Preceding statement. See, this stepwise consists refinements like work out each and every detail for each small piece of manageable solution procedure. Every input and output with and the transformation algorithms implemented in each small piece of solution procedure, which is also known as process, is detailed. Even the interfacing details between each small procedures are worked out. In stepwise, decompose any solution procedure into further smaller pieces and iterate until the desired level of detailed is achieved. In stepwise, group processes together which have some commonality. Okay, group variables together which have some appropriate commonality. Test each small procedure for its detail and correctness and its interfacing with the other small procedures. See, step form, simply we are providing the step by step solution of the given problem. The procedure of solving a problem is stated with the written statement. Generally, we use what? Plain text for providing a solution in the form of step form. Several advantages and disadvantages. Advantages is like it is a step-by-step solution to a given problem, hence easy to understand. It has got a definite procedure which can be exacted within a set period of time. It is very easy to draw a flowchart using algorithm. It has got definite procedures to generate required output. It is easy to debug as every step has got its own logic sequence. It is independent of programming languages. These step form of the pseudocode, step form of the plain text providing a solution of the given problem. So it is not depend upon particular programming. It is independent of all the programming. Several disadvantages like it is time consuming. In larger algorithms, the flow of program control becomes what? Difficult to track. It is difficult to convert it into a flow chart and then it into a program. Algorithm lack visual representation of programming constructions like flowcharts. See why? Because completely it is in the form of text format. It is not in a visual representation or graphical representation. See, this is about what? Step form. And coming to the pseudocode. See, pseudocode is a written form representation of the algorithm. See, it differs from the step form as it uses a restricted vocabulary to define its action of solving the problem. One problem with a human language is that it can seem to be imprecise, like but the pseudocode which is in human language, it tends towards more precision by using a limited vocabularies. Okay, see, simply you can remember it about pseudocode. Pseudocode is a plain language Pseudocode is about what? Plain language description of the steps in an algorithm or another system. Okay, pseudocode is a simple way of writing programming code in English. Pseudo means what? Imitation. Code refers to what? Instructions. Pseudocode uses plain English statements rather than symbols to represent the processes of a computer program. It is to provide high level description of an algorithm. Pseudocode is not an executable program. Pseudocode does not follow the syntax and grammar of any specific computer programming language. Several common pseudocode verbs like input. Say if you are writing any input related data, then you can use the plain English words like read, obtain, get, prompt, like that. For initialization, assigning some values, right? Set, initialize. Add one, I want to increment, like increment. Compute, performing any computations like compute, calculate, determine. See, general English word we are going to be using in the pseudocode. Output, like print, write, display, show. See, these are all the words we are using, what? Common pseudocode verbs. Several benefits of pseudocode, like pseudocode is language independent. It can be used by most programmers. It allows the developer to express the design in plain natural language. It is easier to develop a program from a pseudocode than with the flowchart. Programmers do not have to think about syntaxes. They simply have to concentrate on the underlying logic. The focus is on the steps to solve a problem rather than on how to use the computer language. It is easy to translate pseudocode into a programming language, a step which can be accomplished by less experienced programmers. The use of words and phrases in pseudocode which are in line with the basic computer operations. It simplifies the translation from the pseudocode algorithm to a specific programming language. Unlike flowcharts, pseudocode is compact and does not tend to run over many pages. It's a simple structure and readability makes it easier to modify. Pseudocode allow programmers who work in different computer languages to talk to each other. They can be reviewed by groups more easy than real code. See, these are all what? Several benefits of what? Pseudocode. Some limitations of pseudocode. The main disadvantage of using pseudocode is that it does not provide visual representation or graphical representation or pictorial representation of the program's logic. There are no accepted standards for writing pseudocodes. Programmers use their own style of writing pseudocode. Pseudocode cannot be compiled nor executed, and there are no real formatting or syntax rules. It is simple one step, an important one in producing the final code. See, this is about what? Pseudocode. Remember the point here. Pseudocode is what? Plain language description of the steps in an algorithm or another system. Generally, we use which language? English language for writing the pseudocode. Pseudocode is not an executable program. Pseudocode does not follow the syntax and grammar of any specific computer programming language. Remember it. So this is about pseudocode. We are commonly using pseudocode verbs like for input like read, obtain, get, prompt. For initialization or assigning the values like set, initialize. Add ones like increment. For computationals like compute, calculate, determine. Output purpose, print, write, display, show. See, these are all the common verbs while constructing a pseudocode of the given problem. Okay. Next one about what? Flowchart. See, what is flowchart? Flowchart is a type of diagram that represents a workflow or process. See, a flowchart can also be defined as a diagrammatic representation of an algorithm, a step-by-step approach to solving a task. A flowchart is a visual representation, graphical representation, or pictorial representation of the sequence of steps and decisions need to perform a process. Flowcharts are used in what? Analyzing, designing, documenting, or managing a process or program in various fields. Flowcharts are read from top to bottom and left to right. Reading flowcharts can also be called what? Flowing. How this flow is going to be work. Best suitable examples of flowchart constructions like softwares like Flowgarithm, Raptor, Visual Logic, RoboPro, and VisiRule. See, here we can construct the flowchart, you may get the resultant outputs. See, generally these flowcharts looks in the form of a diagrammatical representation. Once, while constructing the pseudocode, there also you are writing from start, where you are starting the providing a solution of the given problem, and where you are going to be ending start end, or you can write begin end start stop. Okay, these terminologies using for every pseudocode for constructing the or providing solution of given problem. It seems where your problem solution is going to be started and where it is going to be ends. Okay, these terminologies are very important. While constructing flowchart also we are using like where we are going to be started that flowchart or providing a solution of graphical representation and where you are going to be stop. Okay, so this is a general representation. Don't worry about these symbols, we'll discuss in the next slides. Several flowchart symbols are there like terminal symbols are there, input output symbols are there, processing symbols are there, decision symbols are there. See, these terminal symbols, it is used to indicate the point at which flowchart begins and ends, and the word starts or stop is inserted to identifying the point. This is called terminal symbols, we may call it. For input output symbols, see, these symbols identifies the logical positioning of input and output operations. Like IO symbol notes the entry of computer data and the printed output of information. Processing symbols, it's going to be process it like processing related to all types of data is indicated by the processing symbol. These symbols defines computations like calculations, moving data from a storage area to an output area or indicating the sorting and manipulation of data. Next, decision symbols. This symbol you can able to see, right? Decision symbol, logical operations are indicated in flowcharts using what? Decision symbols. A decision symbol has what? Main components. Okay, based on this decision, if it is true it works something, if it is false it going to be execute something. So this is about decision table, but don't worry, we'll discuss each and every flowchart symbol diagram with explanation in the next slide only. Okay, like annotation symbols are there, flow lines are there, connectors are there, like various symbols are going to be represented by what? Flowchart. Several advantages and limitations of flowcharts we'll discuss one by one. So we go with the advantages like communication. See, flowcharts are good visual aids for communicating the logic of a system to all concerned. They communicate the facts of a business problem to those whose skills are needed for arriving at the solution. Next, quicker grasp of relationships. The flowchart helps in identifying the relationship existing among the problem elements. It helps the programmer to understand the current and proposed procedures more easily. Effective analysis, it becomes a model or blueprint of program system that can be broken down into detailed part for study. It helps in identifying the problems and solutions. Effective synthesis, they are used as working models in the design of new program and systems. Elements of old approaches may be combined with new design ideas to give an effective processing plan. That is called effective synthesis. Proper program documentation, they serve as a good program documentation which is needed for the following reasons, like documented knowledge belongs to an organization and does not disappear with the like a departure of the programmer. If programmer are modified in future, flowchart helps the programmer in understanding the current logic. This will aid greatly in future program conversions when new hardware or software packages are acquired. Another advantage is like effective coding. The program flowcharts acts as a guide or blueprint during the system analysis and programmer preparation phase. Instructions coded in programming languages may be checked against the flowchart to ensure that no stops are omitted. Another advantage like orderly debugging and testing of program. See, the flow chart helps in debugging process. It helps in detecting, locating and removing the mistakes. Effective program maintenance. The chart helps the programmer to concentrate attention on that part of the information flow which is to be modified. See, these are all the several advantages of what flow chart. Some limitations of flow charts like complex logic, alteration and modifications, reproduction and standardization. No uniform practice is followed for drawing flowcharts. Like a link between conditions and action, sometimes it is very difficult to establish link between the various conditions and the actions to be taken there upon for a particular condition. These are all some limitations of what flow chart, but you can remember it. In the pseudocode, providing a solution in the form of what plain text language, generally in the form of what English, in the form of what step by step, from start to stop or begin to end. Flowcharts are going to be represented what diagrammatical representation or pictorial representation or visual representation of providing a solution of a given problem or algorithm solution in the form of what diagrammatical representation by flowchart. Here, various types of flowcharts like document flowcharts, data flowcharts, system flowcharts, program flowcharts, modular program flowcharts, detailed program flowcharts, like that. The majorly system flowcharts. It expresses structure and relationship of a system in the form of flowchart. It describes the major operations, both manual and computer, data flow and the files used in the processing and flow of processing control comes under system flowchart. It's showing what controls at a physical or resource level. Second one is modular program flowcharts. These flowcharts are used to represent specific function of a module under the application. It represents the sequence of instructions that perform each procedure or the operation written in independent unit or module. Okay. See, they are also referred to as what? Block diagrams. In case of what? Modular program flowchart. It represents what? Specific function of a module under the application. Third one is detailed program flowchart. These are the more comprehensive and element form of charts used by the programmers. Each symbol represents the executable steps and is suitable for coding as an instructions in the computer language. Generally constructing the flowcharts for what? Research the problems, decide on method of solutions, plan the solutions, outline the system by drawing the system flowcharts, check the system flowcharts, draw the detailed program flowcharts for each program, check the program flowchart, test the program flowcharts, like that. Okay. See, these are all what various constructing the flowcharts. But generally these types of flowcharts are document flowcharts, like showing controls over a document flow through a system. Data flowchart showing a controls over a data flow in a system. System flowchart showing controls at a physical or resource level. Like program flowcharts like showing the controls in a program within a system. Modular program flowcharts like it represents specific function of a module under the application. Detailed program flowcharts more comprehensive and element form of charts using by the programmers. These are all what different types of flowcharts. These constructing the flowcharts. What are the benefits of flowcharts? Simplifying the logic, makes communication better, effective analysis, useful in coding, proper testing, applicable for what? Documentation. See, this is about flowchart. But remember, flowcharts are used to represent what? Diagrammatical representation or pictorial representation. We'll discuss one by one each diagrams are using in the flowchart. This diagram indicates what? Flow line. What we can call it is flow line. A flow line is an arrow that shows the direction which the flow chart will flow. The line in the arrow can be dotted or solid. If the line is dotted, it can be defined in the legend. Second represent what? Terminal. Generally it represent what? Like opening and closing, like start or begin or stop or end of the particular flow chart. Generally represented by what? terminal. Terminals are represented as what? Circles, ovals, like stadiums are rounded, rectangles. See, they usually contain the word start or end for representing the flowchart for what? Start or end, or another phrases that shows the start and the end, such as submit inquiry or receive products. There we are going to be using what? Terminal. Remember, for starting the flowchart, ending the flowchart, we are using the flowchart symbol called terminal symbol. Okay. Next, process. This rectangular box represents what? Process. A process box is represented as a rectangle. This shape is used to show that something is performed. Like example, add 1 to X, or replace identified part, or save changes. These kind of process operations are going to be representing by rectangular box. Next, this diamond box represented by what? Decision. A decision box is represented as a diamond. Is nothing but what? Rhombus, showing where a decision is necessary. Commonly, yes or no questions or true or false test. Each arrow that flows out of a decision box usually should show yes or no or true or false. So generally for conditional statements we are using what? This is decision symbol. Okay. Next, input or output is going to be represented by this symbol. An input output box is represented as what? Parallelogram. This box involves receiving data and displaying processed data. The input output box can only move from what? Input to output, and cannot be done the other way round. Examples like get X from the user, display X. See, this is the representation of what? Input and output representation. Another one called annotation. See, this annotation represents what? Comments or remarks about the flowchart. Annotations have no effect on what would happen to the flowchart. Sometimes the shape consists of a box with what? Dashed or dotted lines. Next one, predefined process. This symbol represents what? Predefined process. Predefined process box are represented as rectangles with a double struck vertical edges. These boxes are used to show complex processing steps which may be detailed in separate flowcharts. Examples like process files. There we are going to be using this symbol, predefined process symbol. Next, preparation. This symbol indicates what? Preparation. Preparation boxes are represented as a hexagon symbol. This may also be called initialization. It shows operation which have no effect other than preparing a value for a subsequent conditional or decision step. Alternately, this shape is used to replace the decision shape in the case of what? Conditional looping. That time this hexagon symbol is going to be using. Generally we call preparation. Another symbol is called on page connector. This symbol indicates what? On page connector. And an on page connector is generally shows as a circle symbol and is used to show more of flowchart in a certain area of the page. Next one, off page connector. So this symbol indicates what? Off page connector. An off page connector is generally represented as a home plate shaped pentagon. It works similarly to the on page connector, except it follows for placing a connector that connects to another page. So these are all the various shapes are used to construct flow chart diagrams based on the pseudocode of the given algorithm, or providing a solution of the algorithm representing diagrammatical representation using these shapes or symbols for constructing what? Flow charts. Okay. Next, some other types of flowcharts see this shape, right? Data files or databases. Okay, just remember. See, observe. See, this shape indicates what? Data file or database. Generally, this symbol data represented by what? Cylinder, like disk drives, specially used for what? Databases, data persistent layers. There we are going to be using this symbol. Okay, it means storage area or data persistent area or databases. Generally we use the symbol called data file or databases. For coming to the documents, here documents like single document represents a rectangle with a wavy base like this one. For multiple document represented like stacked rectangle with a wavy base, this one. For representing what? Document, single and multiple documents. Next, manual operation symbol. It represents by a trapezoid with the longest parallel side at the top to represent an operation or adjustment to process that can only be made manually. For manual operations, we are using this symbol for representing flowchart. Next, manual input. It represented by what? Quadrilateral with the top irregularly sloping up from left to right, like the slide view of a keyboard. See, this is about manual input representation. Next, preparation or initialization. It represented by a hexagon symbol, right? Just previous slide explained. Originally uses for what? Steps like setting a switch or initializing a routine. See, these are all the various symbols are used to represent for what? Flowchart representation, like diagrammatical or visual or pictorial representations. These symbols used to construct what? Flowcharts. Okay. The next type, generally these algorithms are going to be stated or represented in the form of three different forms called Stepform, Pseudocode and flowchart. But also sometimes some books are they are going to be represented what? Nassi Shneiderman diagrams, NSD. See, a NSD in computer programming is a graphical design representation for structured programming. This type of diagrams was developed in what? 1972 by Isaac Nassi and Ben Shneiderman, who were both graduate students at Stony Brook University. These diagrams are also called what? Structograms. See, NSD have no representation for what? Especially what? Go-to statements. They were included in what? Microsoft Visio, Dozens, Easy Code. NSD can also be used in what? Technical writing. See, this is another graphical design representation for what? Structured programming used in what? NSD. See, this is example for what? Representation of NSD diagrams. See, these diagrams categorized again like process blocks, branching blocks and testing loops. Process blocks, the process block representation, it represents the simplest of steps and requires no analysis. When a process block is encountered, the action inside the block is performed and we move on to the next block. Okay, observe here, this is about what? Process block. Here they are going to be performing some action, after that it enters to the next level. See, this type of representation of blocks are called process blocks based on what? NSD diagrams. Second type, branching blocks. There are two types of branching blocks. First is a simple true or false or yes or no branching block, which offers the program two paths to take depending on whether or not a condition has been fulfilled. These blocks can be used as a looping procedure, stopping the program from continuing until a condition has been fulfilled. So observe how it represents what? True or false branching blocks. So this is the way we can represent what? True or false branching blocks. Like open web browser, like whether it is loaded or not. If it is true, it executes something. If it is false, it's going to be execute something. This is another way of representing true or false branching blocks. Not only processing blocks, we can also represent what? Branching blocks. The second type of branching blocks is a multiple branching blocks. See, these blocks is used when a select case is needed in a program. The block usually contains a question or select case. The block provides a program with an array of choice and is often used in conjunction with sub-process blocks to save space. See, this is the second way of representing what? Multiple branching blocks. So this is the representation of what? Multiple branching blocks representation in what? NSD diagrams. Another one called testing loops. This block allows the program to loop one or a set of processes until a particular condition is fulfilled. The process blocks covered by each loop are subset with a sidebar extending out from the condition. There are two main types of testing loops: test first and test last blocks. The only difference between the two is the order in which the steps involved are completed. In the first test situation, when the program encounters a block, it tests to see if the condition is fulfilled. Then if it is not complete, the process blocks and then loop back. the test is performed again, and if the condition is still unfulfilled, it processes again. If at any stage the condition is fulfilled, the program it skips the process blocks and continues onto the next block. The test last blocks simply reverse. The process blocks are completed before the test is performed. The test last loop allows for the process blocks to be performed at least once before the first test. So this is about testing loops. Just observe how it there. The test first loop, what happened? First it going to be test NSD. Search for NS diagrams, read articles is going to be happen. But in case of test last loop block, what happens? First it executes, later it is going to be tested. This is called test last loop block. Another called parallel processing. This is the representation of what? Parallel processing. At a time it going to be execute parallelly block 1, block 2, block 3, block 4 and so on, block n. See, these are all the various representation of diagrams of what? NSD, like process blocks, true or false branching blocks, multiple branching blocks, test first loop blocks, test last loop block, and parallel processing. So in this session we had discussed in detail about what? Various representation of algorithms, or different ways of stating algorithms. Generally it is represented by what? Stepform, pseudocode, flowchart. Sometimes also we can represent it by what? NSD. Okay, here we discussed in detail what is stepform, okay, and what is pseudocode, what is flowchart, and various symbols representing in the flowchart. And also we discussed about in detail NSD. Okay, see, that's it for the today's session. We had discussed in detail about what? Different ways of representation of algorithms. In the next coming session I will explain in detail about with examples of representing the pseudocode flowcharts. Okay, that's it for the today's session. Thank you for watching my videos. Thank you all.